All right, so welcome to your last week of new material. We're going to be doing 2 lessons from 9.3, which is solving our differential equations. So we've talked a little bit about graphing, obviously, with separable equations. And now we're going to look at solving them so that we can actually find that original equation instead of just sketching its graph. So I'm going to break it up into 2 sections. Our first is going to be 6.3135 with presentation number 4. And then we'll look at the next problem set tomorrow, which will be 11 through 19 odd with a presentation of 14. So 2 problem sets from 9.3. You want to get yourself ready for notes, and we're going to get started. So here it's find the solution for these differential equations. We've got 1, we've got 2. Now, the goal here is to find the equation y equals. So if we want to talk about goal for all these problems, we want to find the function y f of x. Now, what we would normally do is we would just take the integral. Since we have a derivative, we want to find the regular function, we'll take the integral. But we have 2 variables in this case, and so this is why you're going to need a different strategy. And these are called separation of variables or separable equations, because that's going to be the first step, is to separate x and y. So you're going to separate the 2 variables. In this case, and this is why I like having it written in what's called Leibniz notation with the fraction, so that you have the x's on one side and the y's on the other. So the first thing I'm going to do is multiply by that denominator. So then I get dy by itself, x times y times dx. Next, what I would do is divide by y. So then I have all the y's on this side and all the x's over here. So then I have dy over y is equal to x dx. Now, since we are going to integrate, I'm going to rewrite this side. We've got 1 over y dy is equal to x dx. So now we have the y's on one side and the x's on the other. This is what it means by separation of variables. Once we have our variables separated, what we want to do is integrate so that we can get rid of our derivative and get the original function. And we just want to integrate both sides, just like we would treating both sides equally, like that. So the integral of 1 over y dy is equal to the integral of x dx. Treat both sides of the equation equally. Now we're going to use our antiderivative skills. The 1 over y is the ln of y, and the integral of x is 1/2 x squared plus c. So don't forget the plus c. And then all you need to do as your third and final step is solve for y. In this case, we want to get rid of that natural log, so raise everything to the e power. So then y is equal to e to the 1/2 x squared plus c. Now this is an absolutely fine final answer. Something you will sometimes see, especially with y's and then raising things to the power, is you could also say that this is the same as y equals e to the 1/2 x squared. Since the exponent is added, that's the same as multiplying by e to the c like this. Usually we're going this way, but it's just as valid to separate that addition. Now e to the c, since c is constant, this is just going to be some other constant. So y is equal to e to the 1/2 x squared, and this is often just written as like a big C like this. So sometimes you'll see the answers to problems with exponents like this as coefficient e to the 1/2 x squared. So this would be the other form that that answer could take. They're both the same, they're both equivalent, but it's nice to see your 2 different options. Let's look at a slightly more complicated problem. So here it says y prime is equal to e to the 2x over 4y to the third. So I'm always going to start by writing it as a fraction so that I can separate the variables. So instead of y prime, it's dy over dx, e to the 2x over 4y to the third. What I'm going to do here is I'm just going to cross multiply to get my variables at the same side. So I've got 4y to the third equals e to the 2x dx. Whoop, forgot the dy. Let's just go back a second. dy is equal to e to the 2x dx. Sorry about that. Now we have our y terms together and our x terms together. So I'm going to integrate both sides. Now, the integral of 4y to the third is y to the fourth. And that's equal to e to the 2x. What I would maybe do here is use substitution, 2x. So then dx is equal to 1/2 x, let's see, sorry about that. Skipped a couple steps, and I don't necessarily want to be doing that to everyone. So then du dx is 2, meaning that dx by itself is 1/2 du here. So then that's 1/2 e to the u du. Y to the fourth equals 1/2 e to the u. And if you remember, u is 2x plus c. Now again, solve for, you want to solve for y, so we're going to take the fourth root of 1/2 e to the 2x plus c, and then you've got your plus and minus because it is to the fourth power, and so with even you need both the plus and minus. Tomorrow we'll look at examples where we find what these plus c values are. Until then, please get in touch if you're